Today in this video we'll be studying about Henry's law. Henry's law, if we compare this statement, like this law is very important for the examinations. If we say that P stands for पक्का, if I'll say पक्का है एग्जाम में, Henry's law is very important. पक्का है एग्जाम में, पक्का है एग्जाम में. So how we'll write it? पक्का है एग्जाम में is constant, suppose. So P will indicate here pressure and KH is Henry constant, while X will give us concentration. And when I am talking about concentration means molarity or mole fraction. So mole fraction is the easiest one concentration, so we can use X for mole fraction out here. So if we take this pressure, so Henry's law states that pressure is directly proportional to mole fraction of the solute. Pressure is directly proportional to the mole fraction of the solute, or P is equal to KHX, where KH is the Henry constant. Now if we just if we use mathematical concept, so we can say that KH is equal to X by P, right? Or X is equal to 1 by KH. This solubility, we can say this solubility or mole fraction, this mole fraction is inversely proportional to the Henry constant out here. The value of KH, this value of KH increases with increase in temperature, okay. Just keep this concept in mind. Value of KH increased with increase in temperature, and we may have question based on this concept. This line will give us several questions. They may be asked in exams, like what happens means why the fish or the fishes why the fishes feel better in cold water in comparison to hot water, comparison to warm water, or in simple words, like in winter fishes are at home while in summer they feel difficulty in breathing and all. The reason is that I told you KH increase with increase in temperature, and we see that the inverse relation between the solubility, this mole fraction indicates solubility of gas, solubility of solute in the solvent. So if KH increase, solubility decrease. KH increase with temperature, means in summer temperature is more, so KH is more. If KH is more, solubility of gas is less, it means solubility of gas is less. And gas, what we know that we all know that we need oxygen, so solubility of oxygen is less when KH is high. When KH is high, it means temperature is high. Temperature is high in summer, so KH is high, so solubility of oxygen in that water is little bit less. That is why fishes have difficulty in breathing. On other hand, if we see winter, in winter temperature decreases, KH also decreases. When KH decreases, then solubility increases. So you got the answer. Now the another example of Henry's law is in the production of carbonated beverages, right? To increase solubility of CO2, CO2 in soft drink, right? Soft drink, soda water, beer, champagne. The bottles are sealed under high pressure. Bottles are sealed under high pressure, right? When the bottle is open under normal atmospheric condition, the pressure inside the bottle, suppose the pressure P inside the bottle fails inside the bottle falls to atmospheric pressure, fall, falls to atmospheric pressure, and the excess CO2 bubbles out. Excess CO2 bubbles out because we have already pressed this CO2 under the atmospheric condition, and the above layer has less density, and here pressure is more. So CO2 oozes out and give us effervescence. This is one more application of Henry's law. At high altitude also, like if we take at high altitude, one more application. At high altitudes, we might have painful effects, right? Painful effects. Why? Because partial pressure of oxygen is less. Partial pressure of oxygen is less than that of the ground level, than of the PO2 at ground level. No, we can say this. Partial pressure of oxygen in high altitude is less than partial pressure of oxygen at ground level. So what actually happens? This result in low concentration of oxygen in blood and tissues of people living at high altitudes or the climbers. The low blood oxygen causes climbers to become weak and unable to think clearly, known as anoxia. And also we may have a concept like why the mountain climbers have cylinder that is mixed with oxygen as well as N2. We know that N2 as literally N2 means azote. This is the poisonous gas. But why we are mixing it with the oxygen in that cylinder? Because uh, N2 help in the maintaining of the pressure. Because as mountaineers are climbing up, means there will be uh, less less dissolution of oxygen into the cylinder, or maybe cylinder will not release O2 continuously. So N2 is there inside the cylinder to maintain the pressure. Like N2 will provide a kind of pressure, it will increase pressure. Let's understand it with the help of an example. Okay, I'm trying to make this concept easier with the help of this example. One question is like this, it is for JEE main. When a gas is bubbled through water at 298 Kelvin, a very dilute solution of the gas is obtained. Henry's law constant Kh for gas at 298 Kelvin is 100 kilobar. 100 kilobar is given. If gas exert a pressure of 1 bar, the number of millimoles, okay, the numbers of millimoles of the gas dissolved in 1 liter of water, in 1 liter of water will, water is, okay, A 0.555, B 5.55, C 0.0555 or D is given 55.5. Now how we'll solve it? Now how we'll solve it? First, mole fraction of gas. Mole fraction of gas, let it is X. We have formula X is equal to P divided by Henry constant KH. Okay, and this one is given 1, and KH is, what is KH? 100 into 10 to the power 3. We can convert it into bar. X 10 to the power 5 minus 5 bar. This mole fraction of the gas in the solution is, if n is the number, let n is the number of moles of gas in a solution of 1 liter of water. We know that 1 liter of water solution, 1 liter of water contains, you must learn these things. So 1 liter of H2O contains 55.5 mole. Okay, you need to learn this in order to save your time. 1 liter of H2O contains 55.5 mole, because several places you need this value. How we got it? We know that number of mole is equal to given mass divided by molar mass. So given mass is 1000 liter or 1 kilogram, whatever is that, and molar mass is 18. So if we divide these two values, we'll get 55.5 mole. So it is better always learn 1 liter of mole 1 liter mole of water 1 liter of water contains 55.5 moles, right? We'll use the formula for mole fraction. X is equal to n upon n plus this moles of solvent. We can take average value n upon 55.5, right? Because the value of n is very less, and this one is given 1 into 10 to the power minus 5 bar. Okay, X is equal to n upon 55.5, that is approximately equal to 1 into given 1 into 10 to the power minus 5. So n, how can we get? N is equal to 1 into 10 to the power minus 5 is equal into 55.5. So ultimately we'll have 55.5 into 10 to the power minus 2 millimoles or 0.55 millimoles. So answer will be which one? 0.55. This A will be the answer, 0.55 millimoles. Okay, this is the process. How can we use Henry constant in order to find the solubility of a gas in the water? Thank you very much for today's class, and I hope this video is gonna help you a lot, and soon we'll meet with another video on the basis of another concept.